In this problem, two charges are 2 centimeters apart and they experience a force of 4 newtons. Now we're going to move them so that their distance is 8 centimeters apart. What is the new electric force? So Coulomb's law tells us that the force between two charges equals Coulomb's constant times those two charges divided by the distance between the charges squared. So we're starting off with our two charges separated only by 2 centimeters. Now we're going to take those two charges, we're going to move them much farther apart relative to where they were, at least 8 centimeters apart. So what we've done right here is we've made this distance 4 times greater than it was in the first place. And so if we apply that same thing right here to our Coulomb's law, if we make this distance 4 times greater, and then we have to square that, well, the Coulomb's constant, the two charges up top, those never changed. And I should have said a 4r right here, 4 times greater than the original distance. Well, this 4 squared becomes 16. So we have that original K, we have charge 1, we have charge 2. Now 4r squared becomes 16r squared. And so if we look at our original force, well, that's still found right here. But now we're taking that original force and we're dividing it also by 16. So because our distance became 4 times greater, our force becomes 16 times smaller. So we can take that original force of 4 newtons, divide it by 16, and 4 over 16, that's just going to be 1/4 of a newton.